Welcome to myprojectbazaar.com. The project title is Supraventricular Tachycardia Classification in the 12-lead ECG using Atrial Waves Detection and a Clinically Based Tree Scheme. The project abstract is: the process begins with initial noise removal and QRS detection. Ventricular features are extracted. According to these features, an initial AEA wave search window is defined and a single AE wave is detected. Atrioventricular nodal re-entry tachycardia. Atrioventricular re-entry tachycardia or sinus rhythm is performed in the framework of the clinically oriented decision tree. Average sensitivity of 83.21%, average specificity of 95.80%, and average accuracy of 93.29% were achieved compared to the definite diagnosis. The project flow diagram is to measure the 12-lead ECG using atrial wave detection. We have to collect the dataset. In the datasets are text or DAT files. On that dataset, we choose that one DAT file or signal. It is our cardiac signal. It is our input signal also. Next, we have to remove the noise from that signal by using Gaussian noise. Next, we have to detect the wave from the signal by using QRS detection. In that QRS detection, to find the wave and heartbeat rate for the given input signal. Next, we have to extract the feature from the measured waves and also find the atrial wave detection to find the wave and RR interval. Next, tree formation for ECG waves, and classify the every patient details for sequentially to measure the ECG wave by using SVM classification. In SVM is support vector machine. Finally, we measure the performance analysis for the detected waves. The project source code file was run from the command window. In current folder shows that the menu file. We have to choose the main.m. It is our source code file. So we have to run the main.m file. After run our source code file, we have to choose the signal. So in that there are many type of signals are there. We have to choose any one of the signal. The process will be going on. So in command window shows the enter the sampling frequency of the signal. So we have to give the sampling frequency, for example 100. According to the frequency value, the result will be shown in the command window. It is the overall result of our process. In figure 1 shows that the 12-lead ECG signal, it is our input signal. In X label shows that the time, and Y label shows that the voltage. In figure 2 shows that the filtering of ECG signal. It is our filtering of our input signal. In X label shows the time in seconds. Y label shows that the voltage. In figure 3 shows that the filtering of our input image with different form. It is our raw ECG signal. After raw ECG signal, we have to apply the low pass filter. In that signal, it is a low pass signal, low pass filter to apply. It is the high pass filter to apply the signal. It is the filter with the derivative filter. It is the average sampling length of noise removal rate. It is the adaptive threshold of our red signal level. In figure 4 shows that the QRS wave detection. To apply the QRS on filtered signal, It is the QRS on MVI signal and noise removal rate, and apply the threshold. It is the pulse train of our found QRS on ECG signal. In X label shows the time and Y label shows that the voltage. In figure 5 shows that the peak detection of our input signal. In that input signal, it is the P wave detection. In figure 6 shows that the maximum beat rate of our ECG signal. It is our maximum heartbeat rate. In figure 7 shows that the accuracy graph. When compared to existing method, the proposed method is high. In X label shows the classification. In Y label shows the accuracy. According to the accuracy graph, the values are shown in the table. In proposed method is 90 and existing method is 62. In figure 9 shows that the sensitivity graph. When compared to existing method, the proposed method sensitivity level is high. In X label shows that the classification and Y label shows that the sensitivity. According to that graph, the sensitivity level is shown on table. Proposed method is high 100% and existing method is 74. In figure 11 shows that the specificity graph. When compared to existing method, the proposed method is high. X label shows that the classification and Y label shows that the specificity. According to that graph, the specificity values are shown in the table. In proposed method is 100 and existing method is 55. In command window shows that the sampling frequency and maximum beat rate level are shown in the command window. Result also shown. When the signals are normal or abnormal, it is also shown in the workspace, and accuracy, sensitivity and specificity values also shown in the command window. So the project demo was completed. Thanks to watching this video.